When a light paddle wheel is placed in path of cathode ray, light paddle wheel is placed in path of cathode ray, it will rotate. Therefore, the conclusion, cathode ray particle have momentum and kinetic energy, right? And when electric field is applied, it attracted towards positive electric field, therefore it is negatively charged, right? Then next one, when magnetic field is placed, it deflects perpendicular direction to the magnetic field, right? So those are the three properties. And then we discussed the when a particle pass through a magnetic field, uh, what happened to that particle. So what is the theory? When charged particle pass through a magnetic field, it will deflect, and the direction of deflection can be determined by using Fleming left hand rule. And when uncharged particle travel through a magnetic field, nothing happen. And particle having magnetic property pass through a magnetic field, it will deflect NO S magnet, right? So those are the three properties. And the fourth property of cathode ray, right? The last property of the cathode ray. So this is a common setup. It's a glass tube. And here this is a cathode. And there is high voltage source. This is anode. Anode. And this is cathode. Right? So here, as cathode, this kind of cathode, this is connected to this position. And as cathode, this kind of cross-shaped cathode is used. Cross-shaped cathode is used. Right? When this kind of cross-shaped cathode is used, then what is observation? Then cathode particle more like this. Then it can be observed that a shadow of this cross, can be observed behind this cross-shaped anode, right? Behind this cross-shaped anode, this is a cross-shaped anode. Then we can observe a shadow. Then what is the conclusion, right? To produce this kind of cross, cathode radiation should be travel from cathode to anode. That is why we can observe a shadow like this, right? Therefore, the first conclusion, cathode ray particle travel from cathode to anode. And the second conclusion is cathode rays travel straightly, right? Cathode ray travel straightly, right? So then using this one, we can conclude there are two properties: cathode ray travel straight line, and cathode ray emitted from the cathode, right? Then write down fourth property. Write down fourth property. When an object like a metal cross, when an object like a metal cross is placed in the path of cathode rays, a shadow with sharp edges of the metal cross, a shadow with sharp edges of the metal cross, a shadow with sharp edges of the metal cross is formed. Metal cross is formed at the end opposite to the cathode. 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 Right. Now draw this one, draw this diagram, draw this diagram. There is a cross-shaped anode, then we can observe a shadow behind the cross-shaped anode. Then the conclusion is cathode ray emitted from cathode and they travel straight line. Draw the diagram. Draw the diagram. Then write down the placement of the shadow. After the diagram, write down the placement of the shadow. The placement of the shadow proves that the placement of the shadow proves that the placement of the shadow proves that cathode rays emit from the cathode rays emit from the cathode rays emit from the cathode and they travel, cathode rays emit from the cathode and they travel in straight line. 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 They travel in a straight line, right? So those are the properties of cathode rays. Then after that, the scientist J.J. Thomson carry out this cathode ray experiment by using different type of gas inside the glass tube and by using different cathode material, right? So that means here is a glass tube. Inside this glass tube, there is a gas, right? And this is cathode ray. Cathode, it is a metal, right? So the metal is changed like a nickel, zinc, Fe, and the gas type of gas like H2, O2, N2, helium, like this, right? By changing the material of cathode and gas inside the tube, the cathode ray experiment was carried out. Then he determined the E divided by M value in each case, right? In each case, he determined the E divided by M value. How he determined the E divided by M value? So last week I told you the magnitude of the deflection. There is a screen, right? And think it's a magnetic field, right? When a particle having charge particle travel through this magnetic field, what happen? It is deflect like this, right? So then this magnitude of the deflection, right? This magnitude of the deflection depends on the E divided by M value, right? So then J.J. Thomson, using a magnetic field, he determined the E divided by M value in each case by changing the gas and by changing the material of the cathode, right? So he observed that in each case, this cathode ray is a screen. In each case, cathode ray hit on the same position, same point. In each case, cathode ray hit same position, right? So then using a method, he determined the E divided by M value. It is 1 minus 1.76 into 10 to the power 8 coulombs per gram. In each case, the E divided by M value is same, right? Then he determined this cathode ray particle should be common to each material. That is why the cathode radiation does not change with changing the gas, type of gas and cathode ray material. In each case, same type of particle is produced as cathode ray. Then he concluded that it is the electron, right? It is the negative charge electron, this cathode ray particle, right? Cathode ray particle. It is negatively charged and have a momentum and kinetic energy like this. Then J.J. Thomson experimentally proved that occurrence of electron in matter, right? Therefore, we can say the electron is discovered by J.J. Thomson. Electron were discovered by J.J. Thomson, right? Write down. Write down. The scientist J.J. Thomson. The scientist J.J. Thomson. The scientist J.J. Thomson. J.J. Thomson carried out. The scientist J.J. Thomson carried out cathode ray experiment. Carried out cathode ray experiment using different type of gases. Using different type of gases. Using different type of gases such as H2, O2, N2, helium, such as H2, N2, O2, helium, and by using different cathode materials, such as zinc, copper, nickel, put a dot. Then he measured the E divided by M value. Then he measured the E divided by M value. He measured the E divided by M value for each situation. By using the deflection through a magnetic field. By using the deflection through a magnetic field. By using the deflection through a magnetic field. Next sentence, write down. Magnitude of the deflection depends on the A divided by M value. Magnitude of the deflection depends on the E divided by M value. Therefore, using that deflection, E divided by M value, A divided by M value can be determined. E divided by M value can be determined. Determine. Next. Write down next. J.J. Thomson observed that J.J. Thomson observed that in every situation, J.J. Thomson observed that in every situation, E divided by M is same. E divided by M value is same. In every situation, E divided by M value is same. It is minus 1.76 10 to the power 8 coulomb per centimeter. This is C, it is a coulomb, the unit used to measure the charge. Coulomb per gram. It is minus 1.76 10 to the power 8 coulombs per gram. Full stop. Then he concluded that cathode ray particle should be common. He concluded that cathode ray particle should be common to each element. Cathode ray particle should be common to each element. 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 That is why same E divided by M is given to each situation. Should be common to each element. Then he stated that that negatively charged particle is the electron. Then he stated that negatively charged particle is the electron. Negatively charged particle is the electron. Therefore, the electron was discovered by J.J. Thomson. Therefore, the electron was discovered by J.J. Thomson. Electron was discovered by J.J. Thomson. J.J. Thomson. Right. So next J.J. Thomson stated that the atom should be electrically neutral. And he experimentally proved that atom contain negatively charged electron. Atom should be electrically neutral. Atom contain negatively charged electron. Then there should be some positively charged something. Right. So then J.J. Thomson introduced his atomic model, we known as a plum pudding model. What is this plum pudding model? He stated that there is a positively charged cloud. Right? There is a positively charged cloud like this. This is positively charged cloud. Positively charged cloud. Right? Positively charged cloud. Inside this cloud, electrons present like this. Inside this cloud, electron present like this. This is an atomic model of Thomson, we known as a plum pudding model. So this plum pudding model introduced by J.J. Thomson, right? So previously, last week we discussed the atomic model of Dalton. It is known as a golf ball model. That means Dalton think the atom like a golf ball, but J.J. Thomson state atom like this. So plum pudding model, right? This is wrong, but this is better than the golf ball model, right? So likewise, the atomic model gradually developed. Then finally, the correct atomic model was introduced, right? So this is a second atomic model, plum pudding model. First atomic model, it is a golf ball model introduced by J.J. Thomson, right? Okay, write down. J.J. Thomson stated that J.J. Thomson stated that J.J. Thomson stated that the atom should be electrically neutral. The atom should be electrically neutral. The atom should be electrically neutral. Electrically neutral. Therefore, electrically neutral. Therefore, there should be positive charge in an atom. Therefore, there should be positive charge in an atom. There should be positive charge in an atom. Positive charge in an atom. In an atom. There should be positive charge in an atom. Then he proposed that electrons present inside the positively charged cloud. Electrons present inside the positively charged cloud. Electrons present inside the positively charged cloud. This model is known as plum pudding model. 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 Right. Draw this plum pudding model. Right. Next one. There is an experiment known as oil drop experiment. Oil drop experiment. This was discovered by Robert Millikan. So this experiment not included in the A-level syllabus, right? So by using this oil drop experiment, we can determine the charge of an particle. So then using this oil drop experiment, the charge of electron was determined. It is charge of electron E, it is minus 1.602 10 to the power minus 19 coulomb, right? This is the charge of electron. Then we know the E divided by M value of electron. J.J. Thomson was discovered minus 1.76 10 to the power 8 coulomb per gram. Then we can substitute here the charge value divided by M minus 1.67 10 to the power 8 coulombs per gram. Then using this one, we can calculate the M value. Here coulomb to coulomb cancels out. Then the mass is 9.107 into 10 to the power minus 28 gram. This is a mass of electron, right? So I will convert gram to kilogram. So you have to divide by 1000. Divide by 1000. So then we can write down mass of electron. Mass of electron. Mass of electron equal 9.107 10 to the power minus 31 kilogram. This is a mass of electron, right? So you can see this value is very small value, 9.107 10 to the power minus 31 kilogram, right? That means the mass of electron is very small, right? Then write down after this diagram, write down to determine the charge of particle, 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 the oil drop experiment can be used. 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 It was introduced by Robert Millikan. 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 Using this experiment, the charge of electron was determined. Using this experiment, the charge of electron was determined. 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 It is minus 1.602 into 10 to the power minus 19 coulomb. It is minus 1.602 10 to the power minus 19 coulomb. 10 to the power minus 19 coulomb. 19 coulomb. By using the E divide by M value, by using the E divide by M value and E, by using the E divide by M value and E divide by M value and E value, E divide by M value and E value, the mass of electron can be calculated. The mass of electron can be calculated as shown below. The mass of electron can be calculated as shown below. Can be calculated as shown below. Okay, write down this calculation. A equal minus 1.602 10 to the power minus 19. Then A divided by M equal minus 1.76 10 to the power 8 coulombs per gram. Then we can substitute the value of A. Then we can determine the M value. It is 9.107 10 to the power minus 28 gram. When it converts to kilogram, 9.107 10 to the power minus 31 kilogram. It is a very small value. Therefore, mass of electron is very small. Okay, write down. Right, after the value, write down this value is very small. This value is very small. This value is very small. Therefore, this value is very small. Therefore, the mass of electron, therefore the mass of electron is very small. The mass of electron is very small. Mass of electron is very small. Right. So that's all about the electron. So the next part, discovery of proton. Discovery of proton. Discovery of proton. Right. So this is an experiment. This is conducted by Eugen Goldstein. Eugen Goldstein. So this Eugen Goldstein is a scientist. Experimentally proved the occurrence of positive charge in matter. Occurrence of positive charge in matter. This is the experiment. This is a cathode ray tube. And here as cathode, I will draw like this. Perforated cathode. That means cathode containing holes like this. This is known as a perforated cathode. Perforated cathode. Perforated cathode is used, and anode and high voltage source like this, right? So then he observed that, so here similarly cathode rays like this, cathode ray travel like this, same way, cathode rays. And other than cathode ray, he observed that another radiation is produced, right? So he observed a red glow behind this perforated cathode, right? This kind of red glow behind the perforated cathode, right? This kind of red glow. So this radiation we known as a canal rays, right? Because Eugen Goldstein think this radiation is produced inside these holes, right? This radiation is produced inside this perforated cathode, inside these holes, this radiation is produced. Therefore, this is known as a canal rays, right? So here what happened? So what are the cathode rays? They are electron, right? Cathode radiations are electron. So inside this glass tube, there is a gas, right? There is a gas. So think like H2 something gas. There is a gas molecule, right? Think this is a gas molecule, the gas molecule. Then as a cathode radiation, electrons travel like this. When this electron hit onto this gas molecule, what happens? The electrons of this gas molecules are removed. This is a cathode radiation, it is an electron. This electron hit onto this gas molecule. Electron of this gas molecules are removed. Then what is the result? due to the removing of electron, this is positively charged, and electron, this electron, that means simply this gas molecule dissociated to positively charged ion and electron. This electron travel towards anode because this is negatively charged. Therefore, this is repelled by cathode because cathode is negatively charged. Negative, negative repel with each other. And cathode positively charged. Therefore, this electron move from cathode to anode. And this positively charged, this is repelled by anode and attracted by cathode. Therefore, what happens? This move anode to cathode, right? This move from anode to cathode. This move from anode to cathode. Then like this radiation move from anode to cathode. Then after that, this radiation move through this canal, through this holes, otherwise canals of this cathode. Then we can observe red glow behind the perforated cathode, right? So therefore, what is this canal rays? They are positive rays, positively charged rays, right? So therefore, this is known as positive rays, otherwise canal rays, right? So then same as previous one, the cathode ray experiment, scientists determine the properties of these canal rays, otherwise positive rays. Similar procedure. First thing, a light pedal wheel is placed. Then what is observation? It is rotated. Then what is the conclusion? They have momentum and kinetic energy. Then cross-shaped object is placed. Then it can be observed that a shadow. Then what is the conclusion? This radiation emitted from anode to cathode and they travel straight way, right? And when an electric field is applied, this is attracted towards negatively charged plate, then it is positively charged. Then last one, when the magnetic field is applied, the positively charged radiation deflect, and the deflection is opposite to the deflection of cathode rays, right? That means if cathode ray deflect like this, then this radiation deflect opposite direction. It can be explained by using the Fleming left-hand rule, right? And similar as a J.J. Thomson experiment, this experiment was repeated by using different type of gas inside the tube. What is a special observation? They observe that according to the gas inside the tube, this cathode radiation is changed. The nature of radiation is changed. That means the speed, A divided by M value, right? And mass, those kind of properties are changed according to the type of gas inside the tube, right? So those are the properties of anode rays, so positive rays, otherwise canal rays, and there is another name, anode rays, right? These are known as anode rays because this radiation move from anode to cathode. Therefore, anode rays, due to the moving of this canal rays, and due to the presence of positive charge, it is known as a positive rays. So those are the properties of positive rays: have momentum and kinetic energy, travel in a straight line and emitted from the anode, and positively charged, do not have magnetic property because only deflection, not attracted towards NOS, and the nature of these anode rays depends on the type of gas, right? Okay, write down the note. First topic, discovery of proton. Then write down the German physicist Eugen Goldstein. The German physicist Eugen Goldstein experimentally proved the existence of positive charge in matter. Eugen Goldstein experimentally proved the existence of positive charge in matter. Existence of positive charge in matter. Existence of positive charge in matter. In his experiment, in his experiment, in his experiment, in his experiment, perforated cathode. In his experiment, perforated cathode, perforated cathode, perforated cathode. Within bracket, write down cathode having holes. Cathode having holes. Cathode having holes. Close the bracket. Was used in a glass tube. Was used in a glass tube. Was used in a glass tube along was used in a glass tube along with air along with air along with air at very low pressure along with air at very low pressure air at very low pressure very low pressure. When a high voltage about 10,000 watt, when high voltage about 10,000 watt, high voltage about 10,000 watt was applied 10,000 watt was applied across the electrode was applied across the electrode across the electrode across the electrode. A faint red glow a faint red glow a faint red glow a faint red glow was observed red glow was observed behind the perforated cathode was observed behind the perforated cathode behind the perforated cathode behind the perforated cathode behind the perforated cathode. Right, draw this diagram, draw this one, draw this diagram. Draw this diagram. Draw this diagram. Right, then write down. Then write down. Write down. Here, 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 cathode radiation, cathode rays, here cathode rays travel from cathode rays travel from cathode to anode. Cathode rays travel from cathode to anode as electron beam. Cathode rays travel from cathode to anode as electron beam, as electron beam, as electron beam, electron beam. These electrons, these electrons, these electrons, these electrons, these electrons, these electrons hit onto the gas molecule inside the tube. These electrons hit onto the gas molecules inside the tube. These electrons hit onto the gas molecules inside the tube, inside the tube, inside the tube, inside the tube. Then electrons, then electrons are ejected from the molecule. Then electrons are ejected from the gas molecules. Electrons are ejected from the gas molecule. Electrons are ejected from the gas molecules. Producing electrons are ejected from the gas molecules, producing positive ion and electron, producing positive ions and electrons, producing positive ions and electrons, positive ions and electrons. These positive ions are repelled by cathode, and attracted by anode, and attracted by anode, and attracted by, repelled by anode and attracted by cathode, and attracted by cathode, repelled by anode and attracted by cathode, attracted by cathode. Therefore, they travel from anode to cathode. 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 anode to cathode. Then positive ions go through the canals of the cathode. Positive ions go through the canals of the cathode. Positive ions go through the canals of the cathode. Go through the canals of the cathode, creating a red glow. Canals of the cathode, creating a red glow. Behind the creating a red glow behind the perforated cathode. Behind the perforated cathode. Behind the perforated cathode. Right. Then write down as a subtopic properties of canal rays. Properties of canal rays, otherwise properties of positive rays. 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 Write down first one. They travel a straight line. They travel a straight line. They travel straight line. They travel a straight line and cast a shadow of the object. They travel in a straight line and cast a shadow of the object placed in their way. They travel in a straight line and cast a shadow of the object placed in their way. Of the object placed in their way. Of the object placed in their way. In their way. Second one. They can move a paddle wheel. They can move a paddle wheel. They can move a paddle wheel. They can move a paddle wheel placed in their path. They can move a paddle wheel placed in their path. Placed in their path. Therefore, they have momentum and kinetic energy. Therefore, they have a momentum and kinetic energy. Therefore, they have momentum and kinetic energy. They have momentum and kinetic energy. They have momentum and kinetic energy, same as cathode ray experiment. Then third one. The rays are positively charged. The rays are positively charged. The rays are positively charged. And the rays are positively charged. And when an electric field is applied, positively charged, and when an electric field is applied, in the path of rays, when an electric field is applied in the path of rays, when an electric field is applied in the path of rays, they are deflected towards the negative plate of the electric field. They are deflected towards the negative plate of an electric field, negative plate of an electric field towards the negative plate of an electric field. Negative plate of an electric field. Then fourth one, when a magnetic field is applied, when a magnetic field is applied, when a magnetic field is applied, they deflected to perpendicular direction of the magnetic field. They deflected to perpendicular direction of the magnetic field. Perpendicular direction of the magnetic field. Perpendicular direction of the magnetic field. Therefore, they do not have magnetic properties. Therefore, they do not have magnetic properties. They do not have magnetic properties. Magnetic properties. Right. Fifth one. The nature of positive rays. The nature of positive rays. The nature of positive rays. The nature of positive rays depends. The nature of positive rays depends upon the gas taken inside the glass tube. Upon the gas taken inside the glass tube. Upon the gas taken inside the glass tube. Different gases give different types of positive rays. Different gases give different type of positive rays. Different gases give different type of positive rays. Different gases give different types of positive rays which contain particles having different masses and different charges. Which contain particles having different masses and different charges. Different masses and different charges. Different charges. Therefore, the E divided by M ratio is not constant. Therefore, the E divided by M ratio is not constant. For positive ray particles is not constant. For positive ray particles obtained from different gases. For positive ray particles obtained from different gases. Obtained from different gases. Obtained from different gases. Right. Different gases. Right. Next one. It's the most important thing. Most important topic, write down production of cathode rays and anode. Production of cathode rays and anode rays when H2 gas is used. Production of cathode rays and anode rays when H2 gas is used. When H2 gas is used. When H2 gas is used. Right. So this is an important part. So when consider H2 gas, it contains a covalent bond like this. I think you know the covalent bond, right? That means this is one hydrogen atom. This is other hydrogen atom. Hydrogen atom contains one electron. That electron shared between two atoms. This is a covalent bond, right? So this kind of covalent bond is present in H2 molecule. So now in this cathode ray experiment, a low pressure condition is applied, low pressure. Due to this low pressure, what happened? The covalent bond between these H2 molecules break, right? Due to this low pressure, the covalent bond between hydrogen atoms are break, creating separate hydrogen atoms, right? Due to the low pressure, the covalent bond is break. Then what is the product? Hydrogen atoms. Initially H2 molecule, now hydrogen atoms, right? Then high voltage is applied in this experiment. High voltage is applied. Using this high voltage, the electrons are ejected. Electrons are ejected, creating H plus and electrons, creating H plus and electron. So like this, so many H plus ions and electrons are produced, right? So these electrons are repelled by cathode because they are negatively charged, attracted by anode because anode is positively charged. Therefore, these electrons travel from anode to cathode as, travel from cathode to anode as cathode radiation, right? Therefore, the movement of electron beam we can observe as cathode radiation. This positively charged H plus ion repelled by anode, attracted by cathode. Therefore, these H plus ions travel from anode to cathode as anode radiation or positive radiation, right? So like this, when H2 gas is used as cathode ray, we can observe the beam of electron, and as anode rays, we can observe the beam of H plus, movement of H plus, right? So next one, the scientist Ernst Rutherford, right? Ernst Rutherford. So this Ernst Rutherford, this positive rays experiment, otherwise canal ray experiment, was repeated, similar as a J.J. Thomson, right? So this Ernst Rutherford, this positive ray experiment, otherwise canal ray experiment, was repeated by using different type of gases. H2 gas, like O2 gas, N2 gas, chlorine gas, like this, by using different gases, right? So then similar as J.J. Thomson experiment, by using different gases, he determined the E divided by M value, right? He determined the E divided by M value. So he observed that according to the type of gas, the E divided by M value was changed, right? But when consider cathode rays, the E divided by M value is constant. It is independent of the type of gas and independent of the cathode ray material. But the E divided by M value of anode rays, otherwise canal rays, is changed according to the type of gas, right? According to the type of gas. So then what he did, so here I will write down gas, then the E divided by M value calculated, right? E divided by M value calculated. Then using this oil drop experiment, we can calculate the E value. Then we can calculate the M value. Do you understand? So here H2. Now think the gas is H2. When H2 gas is used, what is the anode ray? H plus. So here within bracket, I will write down H plus. When gas is H2, as anode ray, H plus is formed. So then using the deflection of magnetic field, the E divided by M value can be determined. Then using oil dope experiment introduced by Robert Millikan, E value can be calculated. By using these two value, the M value can be calculated. I will put like a X. When hydrogen is used, the value is X. Then now think like oxygen is used, or think helium is used. When helium is used, what is the anode ray? It is a helium plus. It is a helium plus, right? Then similarly, E divided by M calculated, and these two values are different, and E calculated, then M calculated. When helium gas is used, the M value is 4x. 4x. Then another gas, like think oxygen is used, then like O plus is formed as anode rays, then E divided by M calculated, E calculated, and the M calculated, he observed that like a 16x, like a 16x, right? So then there is a special observation, right? The E divided by M value is different according to type of gas, right? So then the special observation is the mass value. When hydrogen is used, mass is x, helium is used 4x, oxygen is used 16x. Likewise, the mass of the anode ray particle is whole number multiplication of this H plus. You understand? In any anode ray, the mass of the particle is whole number value of this H plus, right? Here 4x, that means 4H plus, like 4H plus, 16H like a 16H plus, right? So then the Ernst Rutherford made a conclusion. What is the conclusion? He concluded that therefore this H plus should be present in each element in some quantities. Do you understand? This H plus should be contained in some quantities in each element. That means he concluded that this H plus should be common to each element. This H plus is common to each element. Then this H plus ion he named as a proton, right? This H plus ion he named as a proton. Therefore, the proton was experimentally discovered by Ernst Rutherford, the scientist, not a Eugen Goldstein. Eugen Goldstein carried out the experiment by using perforated cathode. He observed a red glow, then the radiation known as a canal rays or anode rays, right? But this experiment developed, and Ernst Rutherford finally determine the occurrence of H plus in each material, and it is known as a proton. Therefore, the proton was discovered by Ernst Rutherford, right? Similarly, cathode experiment, cathode rays produced by cathode ray experiment discovered by William Crookes, right? But by developing that experiment, the occurrence of electron was discovered by J.J. Thomson. Similarly, the anode ray discovered by Eugen Goldstein, but by developing that experiment, the anode rays is produced due to this proton, right? That part was discovered by Ernst Rutherford, right? Ernst Rutherford, right? So then this is H plus is a proton, and the charge of proton is 1.602 10 to the power minus 19 coulomb. That means same as charge of electron, but the difference is the charge of proton is H plus, but the charge of electron is minus. That is the difference. The value is same, the magnitude is different. And the mass of electrons, mass of proton, it is 1.6725 10 to the power minus 27 kilogram. This is a mass of proton, charge of proton, right? So this is the experiment used to discovery of proton, right? Now we can write down the note. Write down. Under this topic, production of cathode rays and anode rays when H2O gas is used. Write down. Due to the low pressure, the covalent bond of H2 due to the low pressure, the covalent bond of H2 is broken. The covalent bond of H2 is broken forming hydrogen atoms, forming hydrogen atoms, forming hydrogen atoms, forming hydrogen atoms, hydrogen atoms by using the energy of high voltage, 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 using the energy of high voltage, by using the energy of high voltage, electrons of hydrogen atoms are removed. Electrons of hydrogen atoms are removed. Electrons of hydrogen atoms are removed. Are removed. Producing electrons of hydrogen atoms are removed, producing H plus cations, are removed, producing H plus cations and electrons, H plus cations and electrons, H plus cations and electrons. Draw this setup, this part, draw this part, draw this part, producing H plus cations and electrons. Draw this part. Draw this diagram. Write down. Then write down. Above electrons are repelled by cathode. Above electrons are repelled by cathode. Above electrons are repelled by cathode and attracted by anode. Above electrons are repelled by cathode and attracted by anode and attracted by anode. Attracted by anode. Therefore, they are traveling from, therefore they are traveling from, they are traveling from cathode to anode, they are traveling from cathode to anode as cathode rays. They are traveling from cathode to anode as cathode rays, as cathode rays, as cathode rays. They are traveling from cathode to anode as cathode rays. Next. The H plus ions are repelled by anode. The H plus ions are repelled by anode, and attracted by cathode. The H plus ions are repelled by anode and attracted by cathode, Therefore, they are traveling from anode to cathode. Therefore, they are traveling from anode to cathode as anode rays. They are traveling from anode to cathode as anode rays. Then write down next sentence. Lord Ernst Rutherford repeated above experiment by using different gases such as H2 gas, helium gas, H2 gas, helium gas, O2 gas, N2 gas, O2 gas, N2 gas. Put a dot inside the glass tube. Then he measured the E divided by M value. In each case. He measured the E divided by M value in each case. He observed that E divided by M value is changing. According to the type of gas. According to the type of gas. The maximum E divided by M value is given. When H2 gas is used. Maximum A divided by M value is given when H2 gas is used. Right? So here the maximum A divided by M value is given when H2 gas is used. The reason is H2 is the lightest gas in the lab. The lightest gas in the lab. It has a very small mass, the light mass, right? Due to the lower mass of H plus, right? The E divided by M value is highest when H2 gas is used, right? The maximum E divided by M value is given when H2 gas is used. Within bracket, you can write down H2 is the lightest gas in lab. H2 is the lightest gas in lab. H2 is the lightest gas. H2 is the lightest gas in lab. But in lab, lightest gas in lab. Next, by using the oil drop experiment, 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 he determined the charge of positive charge particle. By using the oil drop experiment, he determined the charge of positive charge particle of H gas. He determined the charge of positively charged particle of H gas, charge of positively charged particle of H gas. Then, by using E divided by M and E, then by using E divided by M and E, E divided by M and E, E divided by M and E, the mass of positive charge particle of each gas was calculated. Then by using E divided by M and E, the mass of positively charged particle of each gas was calculated. The mass of positive charge particle of each gas was calculated. Each gas was calculated. Each gas was calculated. Next, he observed that the mass of any positive particle, he observed that the mass of any positive particle, mass of any positive particle, mass of any positive particle, mass of any positive particle is a whole number multiplication of, is a whole number multiplication of, is a whole number multiplication of mass of H plus ion, is a whole number multiplication of mass of H plus ion, whole number multiplication of mass of H plus ion, H plus ion. Therefore, Ernst Rutherford concluded that, therefore, Ernst Rutherford concluded that, Ernst Rutherford concluded that the H plus ion is common, concluded that the H plus ion is common to each element, the H plus ion is common to each element, common to each element, and common to each element, and common to each element, and each element should contain some amount of H plus ion. Each element should contain some amount of H plus ion, some amount of H plus ion. So this H plus ion named as proton. So this H plus ion was named as proton. This H plus ion was named as proton by Ernst Rutherford, by Ernst Rutherford, by Ernst Rutherford, Ernst Rutherford. Therefore, the proton was experimentally discovered by, therefore, the proton was experimentally discovered by Ernst Rutherford. Therefore, the proton was experimentally discovered by Ernst Rutherford. Experimentally discovered by Ernst Rutherford. Ernst Rutherford. Ernst Rutherford. Then write down next sentence. Charge and mass of proton are charge and mass of proton are charge and mass of proton are 1.60 to 10 to the power minus 19 coulomb, 1.60 to 10 to the power minus 19 coulomb, and 10 to the power minus 19 coulomb, and 1.6725 into 10 to the power minus 27 kilogram respectively. 1.6725 10 to the power minus 27 kilogram respectively. Kilogram respectively. So the charge of electron and proton are equal. So the charge of electron and proton are equal. The charge of electron and proton are equal. Charge of electron and proton are equal, right? So therefore, the proton was experimentally discovered by Ernst Rutherford, right? But the occurrence of positive particle in matter experimentally discovered by Eugen Goldstein, and cathode ray discovered by William Crookes, but electron was discovered by J.J. Thomson, right? Next topic, discovery of neutron. Discovery of neutron. Right. So this experiment, discovery of neutron experiment, it is a complicated experiment. Therefore, it is not in the syllabus. You have to memorize a scientist. Who are the scientists? James Chadwick. Right. James Chadwick. Right. So this James Chadwick experimented discovered the occurrence of neutron in matter. Occurrence of neutron in matter. Right. So here not the experiment, right? The scientists concluded that other than electron and proton, there should be another particle, right? So I will tell you what is that situation, that experiment. So the experiment is in cathode ray experiment. Cathode ray experiment, a helium gas is used, right? Cathode ray experiment was conducted by using helium gas, and scientists determine the helium gas contain 2 proton, right? Helium gas contain 2 protons. Therefore, the charge should be +2. Then, when helium gas pass through a magnetic field, right? When helium gas pass through a magnetic field, the deflection should be same as a particle having 2 proton. You understand? This is a magnetic field. We can use a Fleming-Hepburn rule. Magnetic field N2S. This is current and force, right? If positive charge particle move like this direction, left to right, then force upside. Therefore, particle should move like this, right? So now think here, there is a particle having 2 proton pass through a magnetic field. It will deflect like this, right? And think a particle having 4 proton, it deflect like this. The deflection is lower than this particle, right? And scientists found that in helium gas, there are 2 proton, therefore it is plus, the charge is +2. Then what they did, they used the helium gas here, right? There is a cathode ray tube, right? Inside that cathode ray tube, helium gas is used, and that positive particle, positive ray, right? Positive ray produced by helium gas pass through this magnetic field, right? Then they expect the path of this helium gas should be same as this path, right? That means the particle having two protons, the path of helium should same as this path. Not 100% similar, but it should be like this, they expect, right? But the observation is different. They observe that the path of helium is same as path of particle having four protons. Do you understand? Experiment determined helium contain two proton. Therefore, the path of helium plus particle should be same this path. They expect, but the observation different. The path is same as the particle having four protons. Then they concluded that in helium, other than proton and electron, there should be another particle. That is the situation. That is a experiment, right? Scientists concluded that in helium, other than electrons and proton, there should be another particle, and the mass of that particle should be same as mass of proton, right? Then after that, J.J. Thomson carried out an experiment. He tried to discover that particle, right? Then J.J. Thomson carried out experiment. Then experimentally he proved the occurrence of neutron in matter, right? That experiment not in syllabus. So here in the under this one, discovery of neutron part, it is enough to remember the neutron was discovered by J.J. Thomson. It is enough, right? So, but I will give this situation, this story. Okay, write down. When helium gas is under this topic, discovery of neutron, write down. When helium gas is used inside the glass tube, when helium gas is used inside the glass tube, helium gas is used inside the glass tube, they discovered inside the glass tube, they discovered helium contain two protons, helium contain two protons, helium contain two protons, helium contain two protons according to the anode ray produced by helium gas. Helium contain two protons according to the anode ray produced by helium gas. According to the anode ray produced by helium gas. Produced by helium gas. Therefore, the deflection of anode ray produced by helium gas, therefore, the deflection of anode ray produced by helium gas should be equal to the particle having two protons, but the experimental observation was different. They observe that the path of anode ray produced by helium gas, the path of anode ray produced by helium gas, when it passed through a magnetic field, when it passed through a magnetic field was equal to the magnetic field was equal to the path of particle having 4 protons. Path of a particle having 4 protons. Path of a particle having 4 protons. 4 protons. 4 protons. Therefore, they concluded that there should be another 2 particle in helium atom. Therefore, they concluded that there should be another 2 particle in helium atom. There should be another 2 particles in helium atom. There should be another 2 particles in helium atom. Helium atom. There should be another 2 particle in helium atom. That is mass is approximately equal to the mass of proton. That is mass is approximately equal to the mass of proton. That is mass is approximately equal to the mass of proton, and charge is 0, and charge is 0, and charge is 0, and charge is 0, and charge is 0. Next, later, James Chadwick experimentally proved the presence of above particle in matter. Later, James Chadwick experimentally proved the presence of above particle in matter. Later, James Chadwick experimentally proved the presence of above particle in matter. Experimentally proved the presence of above particle in matter. It is charge is 0. It is charge is 0. It is charge is 0. Mass is 1.6742 into 10 to the power minus 27 kilogram. Mass is 1.6742 into 10 to the power minus 27 kilogram. Charge is 0 and mass is 1.6742 into 10 to the power minus 27 kilogram. This neutral particle is named as neutron. This neutral particle is named as neutron by James Chadwick. Neutron by James Chadwick. Therefore, the neutron was experimentally discovered by James Chadwick. The neutron was experimentally discovered by James Chadwick. Experimentally discovered by James Chadwick. Right, then I will summarize the theory part. That means discovery of electron, proton and neutron was finished. Then I will tabulize some detail of electron, proton and neutron like this: electron, proton and neutron. So here electron, proton and neutron. First one discovered by the name of scientist we have written, and symbol. What is a standard symbol of electron, proton, and neutron? Next one, mass. No need to memorize the mass value in kilogram. And relative mass. Relative mass. I will tell you what is relative mass. And relative mass. Then charge in Coulomb and relative charge. Relative charge. Electron, proton, neutron. Discovered by scientists. Symbol, mass, relative mass, charge, relative charge. Right, first one. Electron discovered by J.J. Thomson. J.J. Thomson. Proton discovered by Ernst Rutherford. Neutron discovered by James Chadwick. Then a symbol. So electron represented by using simple A, proton simple P, neutron simple N. Simple N. The mass, no need to memorize, 9.107 into 10 to the power minus 31 kilogram. 1.6725 10 to the power minus 27 kilogram. 1.6742 10 to the power minus 27 kilogram. Then how you determine the relative mass? Relative mass means the mass of this particle should be divided by mass of electron. Mass of this particle should be divided by mass of electron. So this one divided by this one, what is the answer? 1. Therefore, relative mass of electron 1. Then 1.6725 10 to the power minus 27 divided by mass of electron 10 to the power minus 31. Then what is the answer? 1837. 1837. What is the meaning of this one? This 1837 means the mass of proton is 1837 times mass of electron. That's the meaning. The mass of proton divided by mass of electron. Then the answer is this one. Then mass of proton is 1837 times mass of electron. Then similarly, the mass of neutron can be divided by mass of electron. Then what is the answer? 1838. 1838. So we can observe, we can see the mass of proton and neutron approximately equal. There is very small difference. If mass of electron is 1, then this is 1837, this is 1838. Then charge minus 1.602 10 to the power minus 19 Coulomb. And this is plus 1.602 10 to the power minus 19 Coulomb. And the charge of neutron 0. Then how you determine the relative charge? The charge of electron should be divided by charge of proton plus value. Then what is the answer? Minus 1. Then 1.602 10 to the power minus 19 divided by 1.602 10 to the power minus 19. Then what is the answer? Plus 1. 0 divided by this value is 0. Right? So therefore, the relative charge of electron -1, proton +1, and neutron 0. Right. Okay, write down this table. Write down this table. Electron discovered by J.J. Thomson. Proton discovered by Ernst Rutherford. And neutron discovered by James Chadwick. The symbol of electron simple A, proton simple P, neutron simple N. And the mass of electron 9.107 10 to the power minus 31 kilogram, proton 1.6725 10 to the power minus 27 kilogram, neutron 1.6742 10 to the power minus 27 kilogram. Then the relative mass can be calculated by dividing the mass of particle by the mass of electron. Then electron 1, proton 1837, neutron 1838, slightly higher than mass of neutron, mass of proton. Then charge -1602 10 to the power minus 19, proton plus 1.602 10 to the power minus 19. The relative charge, electron -1, proton +1, neutron 0. So this mass values no need to memorize, right? You have to memorize the relative charge, relative mass, and the symbol, and the scientist discovered by electron, proton, neutron. Right. So now the discovery of electron, proton, and neutron part was finished, and the John Dalton atomic theory was finished. So next, we can start to discuss the question, right? So next week I will start the discussion of the question in the TEOT, right? So go through the theory part, right? And study well. Then from next week, I will start the question part in the TEOT, right? So then good night all. come back in next week.